Welcome to Jamb Physics revision class. In this class, we're going to go over past exam question on the topic linear motion and projectiles. Okay, let's start with the first question. An Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? A. 838 meters. B. 3,350 meters. C. 670 meters. D. 1,675 meters. E. 67 meters. Okay, from the question we are given the following parameters. An Air Force jet flying with a speed of 335 meters per second. So the first parameter that we are given is the speed. The speed is equals to 335 meters per second. Okay, went past an anti-aircraft gun. How far is the aircraft 5 seconds later? Okay, the time that we are given in the question is 5 seconds. Now, we are asked to calculate how far. How far simply means the distance. Are you getting it? If you look at the question, how far is the aircraft 5 seconds later when the gun was fired? Okay, so we are looking for the distance. Distance is not given. Okay, from this relationship, do you know that speed is equals to distance all over time? Okay, now the speed has been given as 335. So I'm going to have 335 is equals to the distance is what we are looking for. So let us represent it as x. Okay, so I'm going to have x all over the time has been given as 5 seconds. So I'm going to have x over 5. So x will be equals to 335 multiplied by 5. And do you know that distance is measured in meter? You understand? So 335 times 5, that is 1,675. So I'm going to have x is equals to 1,675 meter. Okay. So the correct option to that question is option D. Option D is correct. Okay. Let us proceed to the next question. A palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Okay. Now, please pay attention. I want to introduce you to 3 equations that are important as touching these topics. You understand? And they are called equation of motion under gravity. Are you getting it? The first equation is V equals to U plus GT. Are you getting it? Where A is acceleration due to gravity, like G. G is acceleration due to gravity. Okay? Now, you know, equation of linear motion is V equals to U plus AT, right? Linear motion for linear motion. Now, here it is motion under gravity. Gravitational motion. Motion of an object acted upon by the force of gravity. Are you getting it? So the equation of linear motion is V equals to U plus AT. The second one, S equals to UT plus 1 over 2 AT squared. The third one, V squared equals to U squared plus 2AS. Now, when we are talking about all these 3, they are linear. Are you getting it? Linear motion. Equation of motion. Are you getting it? Linear. Okay. Now, we have the second version called equation of motion under gravity. Okay. That is V equals to U plus GT. The A here changes to G. Are you getting it? The A, which is for acceleration, the acceleration that we are talking about under equation of motion under gravity is acceleration due to gravity. Do you understand? That is why we represent it as G. Do you understand? Okay. The second one is S. S changes to H. You understand? Because in in motion under gravity, we are talking about the distance between an object when it is on the air and the ground level. Do you understand? So we are talking about the height. Are you getting it? So the S here, which is distance, the parallel distance before, changes to H. So I'm going to have H equals to UT plus 1 over 2 gt squared, okay? And the third is v squared equals to u squared plus 2gh. Okay, so master all these three equations as well, okay? Motion under gravity. This equation, they are the equation of motion of an object under gravity, and we're going to make use of one of it to answer the second question, okay? By the way, if you want to learn more on this, there is a link in the description of this class. Kindly check the link, okay? So let's proceed with our question. A palm fruit dropped to the ground from the top of a tree 45 meters tall, okay? How long does it take to reach the ground? Now, the height of the tree, that question now, h equals to 45 meters. Are you getting it? Now, we want to look at how long does it take the fruit to reach the ground. Now, look at the question. How long? How long is talking about the time taken? You understand? How long is talking about the time taken? So, if we have a tree here, are you getting it? Here is the fruit. These are the branches. These are the other branches. This is the ground level. Are you getting it? Now, the fruit drop to the ground. Hello? The fruit, which is this, the fruit drop to the ground. Do you know that the initial velocity of the fruit is 0? Are you getting it? So u will be equals to 0. Are you getting it? Don't worry, it's simple. It's simple. The fruit is attached to a branches of the one branch of the tree. Are you getting it? Now the fruit before is not moving before, so the initial velocity is considered as 0. Now we want to calculate the time. The velocity was not given as well. We are interested in calculating the time. So t, we are looking for t. And now because this fruit dropped from this point to the ground, the kind of acceleration that we are going to be introducing is acceleration due to gravity, that is g. So g equals to, in fact, we are giving g as 10 meters per second. So g equals to 10 meters per second. Okay, with respect to the parameters that we have on the board, which of the equation of motion are we going to use? We know that h, we are given h. Hello, we are given h. We know that u is 0. Initial velocity is 0. We are looking for the time. And we know that g equals to 10 meters per second as it was given in the question. Which of these equations are we going to use? If you want to use the first equation, you don't know the value of the final velocity, which is v. So you can't make use of it. Likewise, if you want to make use of the third equation, you don't know the value of the final velocity, so you cannot make use of that. The equation that you're going to use is the second equation, which is h equals to ut plus 1 over 2 gt squared, okay? So let us plug in our value to calculate the time. So I'm going to have h equals to ut plus half gt squared, right? H has been given as 45 meters, so I'm going to have 45 is equals to 0 multiplied by time plus 1 over 2 multiplied by 10 multiplied by t squared, okay? So 45 is equals to 10t squared all over 2, because 0 times t will give me 0. Are you getting it? So I'm going to have 10t squared is equals to 45 times 2 is what? 90. So I'm going to have over 90. Equals to 90. So this over 10 and this over 10. T squared is equals to 9. To get the value of t, you square both sides. You take the square root of both sides. So here I'm going to have t equals to 3 seconds, okay? The correct option to that question is option E. Option E is correct. Option E is correct. The figure below shows the velocity time graph of a car which starts from rest and is accelerated uniformly at the rate of 3 meters per second squared for 5 seconds. It attains a velocity which is maintained for 1 minute. Another 3 seconds. Calculate the total distance covered. A, 900 meters. B, 1,920 meters. C, 1,020 meters. D, 960 meters. E, 860 meters. Okay, please kindly pay attention. the velocity time graph, I've already do it on the board, okay? So we're going to make use of this diagram to answer this question. Let us look at the progression of the movement of the body. The car accelerated uniformly at the rate of 3 meters per second squared for 5 seconds. Acceleration on this velocity time graph is when the car moves from this point to this point, because you can see that from the line from this point to this point means the acceleration is increasing. This is the velocity and this is the time. And acceleration tells us how fast the velocity of an object is changing, right? So the velocity changes from 0 to this point. You can see that it accelerates. Are you getting it? So the line here, and for that seconds, the seconds is what? 5 seconds. For that acceleration, the seconds is 5 seconds. So from this point, I'm going to have 5 seconds here. So now after 5 seconds, it maintains that velocity for 1 minute. How many seconds are you going to see in minutes? That is 60 seconds, right? So when it maintains the velocity, it covers it covers from this point to this point. Okay, so that means the time from here to here is 60 seconds. Are you getting it? So the time from here to here is what? 5 seconds. From here to here is 60 seconds. Are you getting it? Now, if I want to calculate the distance from this point, the time, sorry, I'm talking about time now. The time from this point to this point is what? That is 60 plus 5, right? That is what? 65 seconds. Are you getting it? Okay. Now, another 30 seconds. Do you know the meaning? Another 30 seconds means the velocity reduced. Are you getting it? There is decrease in velocity for another 30 seconds. And you can see that it comes from here down. Are you getting it? The velocity, having attained a uniform velocity, it's used to cover this. Now, having gotten to this point, the velocity decreases. And the time of decrease is what? 30 seconds. So the time from this point to this point is what? 30 seconds. That means if I want to write out the time for the whole journey, it will be what? 5 seconds. 5 seconds plus 60 seconds plus 30 seconds. That is what? 68 seconds. Are you getting it? So now we are asked to calculate the total distance traveled by the car. To get the total distance, we first need the velocity. Are you getting it? The maximum velocity. We need the maximum velocity. And since we know that acceleration has been given as 3 meters per second, 3 meters per second squared. And acceleration is equals to velocity all over time, right? Okay. Now the time it's used to accelerate is what? 5 seconds. Are you getting it? So I'm going to have theory equals to velocity, which you are looking for, all over time. The time is what? 5 seconds. Don't forget. So I'm going to have v over 5. Okay. That means velocity equals to 15 meters per second. Okay. So the velocity that it attained, the velocity it attained when it accelerates for 30 meters per second squared is what? 15 meters per second. Okay. Now we can calculate the area, the total distance traveled by the car. The total distance traveled by a car is the total area. Are you getting it? The area of the shape will give us the total distance traveled by the car. So now let's go. What is the shape that we have on the board? The shape is trapezium. Are you getting it? So that means you have to know the formula for calculating the area of a trapezium. Area of a trapezium is equals to 1 over 2 a plus b multiplied by h. Are you getting it? Which is also the same thing as a plus b multiplied by h all over 2. That is the area. Are you getting it? So let's proceed. Area is equals to, now a and b are the parallel side of the trapezium, because if I want to bring out this diagram, I'm going to have something like this. If I want to bring out the diagram, I'm going to have something like this, right? Where this is what? 60 seconds. 60. And the total distance from this point to this point is what? 68. And the height, which is the velocity that it attained, is what? 15. Do you understand it now? So let us substitute. This one is A, this is B, and this is the H. Are you getting it? So A is 60. 60 plus 68 multiplied by 15 all over 2, okay? So you're going to have 128 multiplied by 15 all over 2. 128 times 15. That is 1920. 960. So the distance traveled by the car is 960 meters. Let us look at the correct option. The correct option is option D. Option D is correct, okay? Option D is correct for this question. I hope you understand. By the way, if you want to learn more on velocity time graph, I did a comprehensive class. You can check the link in the description of this video, okay? The motion of the moving skin of a talking drum can rightly be described as A. Translational motion, B. Random motion, C. Rotational motion, D. Oscillatory motion, E. Transitory motion, okay? Now, what is translational motion? Translational motion is a motion of an object in a linear form. Are you getting it? It's also known as linear motion, so that cannot be the answer. Also, random motion. Motion that doesn't follow a particular direction. For example, motion of a bee. Translational motion. I'm coming. Translational. Just motion of an object in a straight line. Then we have the second one, random motion. Something like this. Are you getting it? Motion of a bee. Are you getting it? Just moving. The next one is rotational motion. Rotational. Rotational, that is in form of a circle. Are you getting it? Then we have the next one, which is oscillatory. Oscillatory motion is the motion of an object that is moving to and fro. Are you getting it? To and fro. That is the kind of motion. Are you getting it? So if you look at the last one, transitory, there is nothing like that motion. Are you getting it? So the correct option is option D. Because if you beat a drum, if you beat a talking drum, it will cause the skin to contrast. Are you getting it? It will cause it to contrast, and also it will expand. Are you getting it? So it is this motion, rotational motion. Are you getting it? You have to know the reason why an answer is not correct before you can get the answer to a question. You have to know the reason why other options are not correct. Are you getting it? That is why I take time to explain each option one by one, okay? Let's look at the next question. The driver in a motor car of which the total mass is 800 kilograms and which is traveling at 20 meters per second suddenly observes a stationary dog in his path 50 meters ahead. If the car brakes can exert a force of 2,000 Newton, what will most likely happen? Okay, A, the car will be able to stop immediately the driver notices the dog. B, the car will stop 30 meters after hitting the dog. C, the car will stop 20 meters in front of the dog. D, the driver will quickly reverse the car. E, the car will stop 5 meters beyond the dog. Now, listen to me carefully. This is a scenario question. Are you getting it? So I want you to pay attention. The mass, we are given mass as what? Mass is equals to 800 kilograms from the question. And the driver is traveling at 20 meters per second. You understand? That is the velocity. Velocity is equals to 20 meters per second. Are you getting it? Now, the distance between the car, listen to me carefully. Let's say this is the car. This is the car. Are you getting it? And a dog was positioned here. The distance between the car, when the driver observed the dog, are you getting it? The distance between them is what? 50 meters. Okay? Our goals, listen to me carefully. Our goals here, in fact, force is equals to 2,000 Newton. Our goals here is to find the distance. The distance, when the brake is applied, it is impossible for the car to stop at that moment. Are you getting it? So we have to find the distance the car covered when that brake is applied. Are you getting it? So that is the distance that we want to calculate now. Okay. Don't forget that Newton's second law of motion, force is equals to mass times acceleration, right? Okay. So 2000 is equals to the mass, which is 800 multiplied by the acceleration. Why do I need to get the acceleration? The reason why I need to get the acceleration is simply because I want to make use of the law of Newton. You understand? I want to make use of Newton's laws of motion. So, and I need acceleration. Okay, so here you're going to divide both by 800. This over 800 also. So A is equals to 2.5 meter per second squared. Now, this kind of acceleration is retardation. Do you know why? Because when the brake is applied, the acceleration begins to decrease and the velocity decreases as well. Are you getting it? So I'm going to have negative sign here. Do you understand? If you didn't understand, that means you have not learned, you didn't have a comprehensive understanding on Newton's laws of motion. So if you want to learn that, there is a link in the description of this class. There's a link in the description of this video. Kindly check the link there and click on that link to watch those classes, okay? So let us proceed. Here, I've gotten A as negative 2.5 and V. Listen to me. The V that you have here is initial velocity. Are you getting it? The final velocity will be 0. Do you understand? Because before the brake was applied, the velocity which the driver was using to move, the velocity which the driver is moving with is what? 20 meters per second. So that is the initial velocity. Let us represent it as U. Okay? So here V will be 0. The final velocity will be 0 because the final velocity, when the brake was applied, the velocity began to decrease. And at the end of the day, the car will stop moving. So V will be 0 here. So having known that our V is 0, U equals to 20, A equals to negative 2.5 meter per second squared, meter per seconds. I gave you 3 equations of motion the other time for linear motion. V equals to U plus AT. Do you know? The second, S equals to UT plus 1 over 2 AT squared. Do you remember? And the third, V squared equals to U squared plus 2 AS. Based on that information that I gave you, which one are you going to use? Do you know that we are looking for the distance? We are looking for S. I hope you are aware. Because we want to find the distance that the car covers when the brake was applied. Do you understand? So here I'm going to have V squared equals to U squared plus 2AS. This is the formula that contains all the parameters that I need. So 0 equals to U squared. U is 20. So I'm going to have 20 squared plus 2 multiplied by negative 2.5 multiplied by S. S is unknown. So I'm going to have negative 20 squared equals to negative 5. Yes, negative 5S. To get the value of this over negative 5 and this also over negative 5. Are you getting it? Now, S, the distance is equals to 80 meter. Do you know why? That is the distance that the car covers when the brake was applied. And you can see that the distance between the car and the dog is what? 50 meters. So that means if this is the point where the brake was applied, that means the car covered the distance more than the distance between the car and the dog. Are you getting it? The car covered the distance because you can see S equals to 80 meters here, and 80 meters is greater than 50 meters. Is that not it? That means the car did not stop until he hit the dog. And after hitting the dog, it also covered a distance. That distance is 80 meters minus 50 meters. That is what? 30 meters. I hope you understand the analysis. It's simple. Honestly, it's simple. All you have to do is just be able to analyze the question and you are good to go. So here, the answer is 30 meters. And this, the correct option to that question is, the car will stop 30 meters after hitting the dog. Are you getting it? If the distance between the car and the dog is 50 meters, and the car stopped after 80 meters when the brake is being applied, that means it hit the dog and it's also continued. Are you getting it? And it covers a distance of 30 meters after eating the dog, because we know from the question that the distance when the brake was applied and where the dog is, the distance is 50 meters. So a body falls freely under gravity from a height of 40 meters onto the top of platform 0.8 meters above the ground. Its velocity on reaching the platform is A. 784 meters per second, B. 80 meters per second, C. 78.4 meters per second, D. 39.2 meters per second, E. 27.7 meters per second. Okay, let's start by writing out the information that we are given in the question. We are given that the height which the body falls is what? 40 meters. H equals to 40 meters. Are you getting it? Then the body falls on a platform which is 0.8 meters above the ground level. That means the height of the platform is 0.8 meters. The height of the body, the distance between the body and the ground level is what? 40 meters. This height that you see here is the height from the ground level. The height of the body from the ground level. From the ground level. I'm going to draw the diagram, don't worry. Equals to 40 meters. Let's say this is the body, okay? This is the body. The height of the body, this is the ground level. Are you getting it? The height of the body from the ground level is what? 40 meters. Now the body falls on a platform. This is the platform. The platform is 0.8 meters above the ground level. The height is what? 0.8 meters. Are you getting it? So the body falls on this platform. This is where the body falls to. In the question, we were told that the body did not fall on the ground. It fell on this platform. Are you getting it? And that information is very, very important. So take note of it, because I will tell you where most people make the mistake. Most people use this height. And the height that you are going to use is the height from this point to this point. Are you getting it? Just pay attention. We are asked to calculate the velocity on reaching the platform. Now, the initial velocity of the body is what? Is 0. So U equals to 0. We are looking for V, which is the final velocity. Now, the height is equals to what? 40 minus 0.8 meter. This is what I'm talking about. Listen to me carefully. If the distance of the body from this point to the ground level is 40 meters, and the body did not fall, it doesn't fall on the ground, it fell on this platform, and the platform is 0.8 meters above the ground level. That means the distance between the body and the platform and the top of the platform is what? 40 minus 0.8, and that is 39.2, okay? H equals to 39.2 meters. Are you getting it? So now, we are going to make use of equation of motion under gravity. We know V. We know that U is 0. V is what we are looking for. H is 39.2. Which equation are we going to use? We are going to make use of V squared equals to U squared plus 2GH. Are you getting it? I gave you 4. Okay, let me just write it again. V equals to U plus GH. V squared, okay, plus or minus. V squared equals to U squared plus or minus 2GH. H equals to UT plus, okay, plus or minus 1 over 2 GT squared, okay? This theory equation is very important. Are you getting it? So master them if you have not. And if you missed the previous class, I was touching this revision, kindly check the link in the description of this video, okay? This is the second class, okay? So now, we're going to make use of this equation. V equals to U squared, which is what? 0, plus 2 multiplied by G. G is the acceleration due to gravity, and it has been given as 9.8 meter per second squared. Okay, so I'm going to have times 9.8 times the height. The height now is 39.2. So 39.2, 39.2. Okay, V squared equals to, now punch your calculator, 2 times 9.8, 2 times 9.8 times 39.2, that is 768.32. So take the square root of both sides. V equals to 27.72 meter per seconds. So V equals to 27.7 meter per seconds. So the correct option to that question is option E. Option E is correct. Okay? Option E is correct. Now, you can see that the question is twisted, but when you understood how to get the important information from a question, you'll be able to solve the question. Okay? Now, let's look at the next question. Two particles X and Y starting from rest cover the same distance. The acceleration of X is twice that of Y. The ratio of the time taken by X to that of Y is A 1 over 2, B 2, C 1 over root 2, D root 2, and E 4. Okay? Please pay attention. Two particles X and Y. Okay? X, Y. Both of them start from rest. Now, listen to me carefully. Since they start from rest, that means that the initial velocity of X is what? 0. Also, the initial velocity of Y is also what? 0. Because from the information that we are given, we are told that both of them start from rest. Okay? Now, the acceleration of X is twice that of Y. Acceleration of X is equals to 2 times acceleration of Y. Okay? Let acceleration of X equals to AX. In fact, let me write it out. Let the acceleration of X equals to AX, and let the acceleration of Y equals to AY. Now, we are asked to calculate the ratio of their time taken. The time taken by X to that of Y. Now, listen. From the equation of motion, S equals to UT plus 1 over 2 AT squared. Do you know the reason why we are going to make use of this equation? The simple reason is because both particles cover the same distance, you understand? And S stands for distance. So this is the equation of motion that you are going to make use of. So please kindly pay attention. I'm going to erase this now. Now, the distance covered by particle X, will be equals to the initial velocity multiplied by the time, are you getting it? Plus 1 over 2 acceleration of X multiplied by the time taken to cover the distance. This information that you see here is for X alone. Are you getting it? So here I'm going to have the distance covered by particle X will be equals to initial velocity is 0. So 0 times t will be what? 0. So I'm going to have AX t square X all over 2. Are you getting it? And from the question, we are given that the acceleration of particle X is twice that of Y. So I'm going to replace this acceleration as 2 multiplied by the acceleration of particle Y. So I'm going to have the acceleration, okay, the distance covered by particle X equals to 2 multiplied by acceleration of particle Y multiplied by the time squared. Are you getting it? This all over 2. Call this one equation 1. Are you getting it? Now, we are still on the question. For particle Y, the distance covered by particle Y will be Sy equals to Uy Ty plus 1 over 2 multiplied by Ay T square Y. Are you getting it? Now, because the initial velocity for both is 0, so this is what 0 times ty. That is what 0. So I'm going to have the distance covered by particle y will be equals to ay t square y all over 2. Are you getting it? Okay, call this one equation 2. Equation 1, which is x, the distance covered by particle y, can be simplified. Divide this by 2. I'm going to have ay t square. Are you getting it? That is the simplified version. That is the simplified version of this. All I did was that I just divide this 2 by this 2. So I'm left with what? Ayt square x. Are you getting it? So let us proceed. The next step, oh sorry, shit. Now the next step is that I'm going to divide equation 1 by equation 2. So I'm going to have sx. I'm going to have sx all over the distance covered by particle y equals to ay t square x all over the equation 2 is what? Ay t square y all over 2. You remember? Okay. So yeah. Now, because the distance is the same, hello, the distance covered by both particles is the same. So that means this will give me 1. Are you getting it? The distance covered by particle x is the same as the distance covered by particle y. Are you getting it? The only difference is the acceleration, and because there is difference in acceleration, the time will also be differs. Are you getting it? So I'm going to have 1 equals to ay t square x divided by acceleration of y t square y all over 2. This all over 1. Okay. So 1 equals to ay t square x all over 1 times 2 all over ay t square y. Okay. I can erase this, right? Yes. Okay. So here I'm going to have 1 equals to 2 multiplied by ay t square x all over ay t square y. Now listen, this ay can cancel this ay. Are you getting it? So I'll be left with 2t square x all over t square y. Now don't forget, our goal is to find the ratio of the time taken of that of particle x to that of particle y. So don't forget our goal. So here I'm going to multiply 2t squared equals to t square y. Now, since my intention is to find the ratio of the time for particle x to that to the ratio of the time for particle x and that of particle y to that of particle y, I'm going to divide both sides by what? T square y. You see, this t square y represents the time taken for particle y to cover that distance. Do you understand? So I'm going to have this over t square y and this over t square y. So this will be 1. Sorry, let me just put it here. This will be 2t square x all over t square y equals to 1. Now, I'm still going to divide both sides by 2. Are you getting it? I'm going to divide both sides by 2. So this over 2 and this over 2. These 2 will cancel these 2. So I'm left with what? T square x all over t square y equals to 1 over 2. I'm still not done with the question. You see, if you're solving this in Jamb, you didn't have to show all this solution. You see, just within a short period of time, you can get your answer. But the reason why I show all this step is because I'm explaining, okay? And I want you to understand, okay? Now, here I'm going to have, if you have, remember this property, a squared all over b squared can be written as what? A over b squared, right? Yes. So that means t square x over t square y can be written as t subscript x all over t subscript y squared. this will be equal to what? 1 over 2. Okay, to get the value of the ratio of the time that particle X used to cover the distance to that of particle Y that it used to cover the distance, I'm going to take the square root of both sides. So I'm going to have the square root here. This will cancel this. So I'm going to have t subscript x all over t subscript y equals to the square root of 1 over 2. Now, remember these properties. If you have square root of a over b, it can be written as square root of a all over square root of b. Are you getting it? That means, sorry, I have to erase this. So, t subscript y equals to square root of 1 is what? 1. And square root of 2 is what? Is root 2. The correct option to this question is option C, 1 over root 2. Option C is correct. Okay, let us proceed to the next question. A mango fruit drops from a branch 10 meters above the ground. Just before hitting the ground, its velocity is A, 10 root 2 meters per second, B, 10 over root 2 meters per second, C, 100 meters per second, D, 5 root 2 meters per second, E, 200 meters per second. Okay? A mango fruit drops from a branch 10 meters above the ground level. So the height has been given as 10 meters. Also, we are given that G, acceleration due to gravity, is what? 10 meters per second squared. Okay? We are asked to calculate the velocity. And because the mango tree dropped, that means that the initial velocity is what? 0. So U equals to 0. Do you understand? I hope you understand the question. The body is not moving before. Are you getting it? So the initial velocity will be 0. Now, based on the information that we are given, what will be the value of the velocity? How can we determine the velocity? Recall the equation of motion. V squared equals to U squared plus 2GH. Are you getting it? This is one of the important equations of motion that I asked you to master. And the value of G depends on the direction of the free fall. You understand? Since the body is moving towards gravity, that means the value of G will be positive. Are you getting it? If the body is thrown up, the value of G will be what? Negative. Are you getting it? So that is why I have plus in this place. So let us proceed. V squared is equals to U squared. U is unknown, so I'm going to have 0 plus 2 multiplied by U is 0, sorry, times 10 times 10. Okay, so V squared equals to the square root of 200. The square root of 200. So V will be equals to square root of 25 times. So V will be equals to square root of 25 multiplied by the square root of 8. Are you getting it? Okay, now square root of 25 is what? 5. And square root of 8 can be written as 4 times 2, right? So V equals to 5 times square root of 4 times square root of 2. Are you getting it? V is equals to 5 times 2 multiplied by the square root of 2. Okay? So V is equals to 10, because 5 times 2 is 10, root 2 meters per second. Okay? The correct option to that question is option A. Option A is correct. Okay? Let us proceed to the next question. Which of the following statement is true of a body which is moving in a straight line with uniform acceleration? A. The velocity of the body is also uniform. B. The velocity of the body must always be 0 when the body stops accelerating. C. The velocity of the body will increase with time in the direction of the acceleration. D. The velocity of the body is equal to the quotient of the distance traveled and time. E. The velocity of the body is the product of the distance traveled and time. Now, what do you understand by uniform acceleration? When the acceleration of a body increases at the same rate, are you getting it? When there is increase in acceleration of the body with respect to time, when it is constant, that is called uniform acceleration. Are you getting it? It doesn't mean the acceleration is not increasing. Are you getting it? But okay, let me cite an example. Let's say, please pay attention. Let's say we have a ball. Are you getting it? Let's say we have, or maybe let me call this a car. I don't know how to do it, don't worry. Let's say this is a car. The car moves from this point to this point. And it also moves from this point to another point. It also moves from this point to another point. Now, let's say the acceleration that the car used from this point to this point is 10 meters per second squared. The acceleration from this point to this point is also 20 meters per second squared. This is 30 meters per second squared. Now listen, you can see that the acceleration increases, but it is constant. Do you know? Because if you take the difference between 20 and 10, you're going to have what? 10 meters per second squared. If you take the difference between 30 meters per second squared and 20 meters per second squared, you're going to have what? 10 meters per second squared. So that is uniform acceleration. Now, when the acceleration increases, what happens to the velocity? Velocity also increases. So that it is uniform doesn't mean it doesn't increase. Are you getting it? Uniform simply means it increases at a constant rate. Are you getting it? So now that means the correct option to that question is that the velocity will increase with time in the direction of the acceleration. Why? Because acceleration tells us how fast the velocity of an object is changing. So the correct option to that question is option C. Yes, option C is correct. Okay, option C is correct. Okay, now let's look at the next question. A train has an initial velocity of 44 meters per second and an acceleration of 4 meters per second squared. Its velocity after 10 seconds is A, 2 meters per second, B, 4 meters per second, C, 8 meters per second, D, 12 meters per second, E, 16 meters per second. Okay, I'm coming. Let's start by writing out the information that we're given in the question. We are given that a train has an initial velocity of 44 meters per second. So U equals to what? 44 meters per second. Are you getting it? And acceleration of 4 meters per second squared. A equals to 4 meters per second squared. Its velocity after 10 seconds. The velocity is what we are looking for. That is the final velocity. And the time that we are given in the question is what? 10 seconds. Okay? With respect to the information that we have on the board, how can we calculate the velocity of the body? Remember that V equals to U plus AT, right? So V equals to, now U is what? 44. 44 plus, now the acceleration here will be retardation. Do you know why? Because the initial velocity of the body is 44 meters per second. The velocity will be reduced. And what causes the velocity to reduce is because the acceleration also reduces. Are you getting it? There is negative change in acceleration. So the acceleration that we're talking about here is negative acceleration. Do you understand? And negative acceleration is what? Retardation. Okay, now take for instance, you are in a bus and the bus is moving with a velocity of 44 meters per second before. Now a brake is applied to the bus. What will happen to the velocity? The velocity will decrease, right? Now, what causes the velocity to decrease is the application of the brake. The braking force is what makes the velocity to decrease. Now, the acceleration of that bus will be negative. Are you getting it? Because the speed is decreasing. So that means the acceleration here will be negative. So I'm going to have minus 4 multiplied by the time, which is 10 seconds. Okay, so V will be equals to 44 minus 4 times 10 is what? Negative 40. Plus 1 times negative 40, that is what? Negative 40. So I'm going to have V equals to 4 meters per second. And the correct option to that question is option B. Option B is correct, okay? That is the solution to that question. A car moving with a speed of 90 kilometers per hour was brought uniformly to rest by the application of the brakes in 10 seconds How far did the car travel after the brakes were applied? A. 125 meter. B. 150 meter. C. 250 meter. D. 15 kilometer. Okay, let's start by writing out the parameters that were given in the question. We are given that the car is moving with a speed of 90 kilometers per hour. That means that speed is the initial speed. Are you getting it? That is the initial velocity. Initial velocity equals to 90 kilometers per hour. Are you getting it? And we are given that the time equals to 10 seconds. Okay. Now, if this is the initial velocity, the final velocity v will be equals to what? 0. Are you getting it? So now, before we can proceed with the calculation, we need to change this to meter per second. Are you getting it? Now, don't forget that 1,000 meter equals to 1 kilometer. Are you getting it? And 60 minutes equals to 1 hour, and 60 seconds equals to 1 minute. That means that 3,600 seconds equals to 1 hour. Are you getting it? Because if you take the product of 60 and 60, you're going to have 3,600. Are you getting it? So let us convert 90 kilometer. 90 kilometer per hour equals to 90 multiplied by 1,000 all over 3,600. Are you getting it? So this will eliminate this. So I'm going to have 900. Yes, 900 all over 36. This will give me 25 meter per second. So the initial velocity u equals to 25 meter per second. Okay. So now with respect to the information that we're given, we're asked to calculate how far. That is the distance. Are you getting it? So we're going to make use of this formula. Distance is equals to v plus u multiplied by t. V plus u multiplied by t all over 2. Are you getting it? So the distance s will be equals to v is 0. So I'm going to have 0 plus u. U is 25 meters per second. So I'm going to have 0 plus 25 all over 2. This multiplied by the time, which is 10 seconds. Okay. 2 here 1, 2 here 5. Are you getting it? 0 times 0 plus 25 is 25. 25 times 5 is 125. So the distance that the car covers after the brake was applied is what? 125 meters. Do you understand? Okay, let's proceed to the next question. What is the average velocity of the sprinter whose velocity time graph is shown in the figure above? Now, this is the velocity time graph that they are referring to. Are you getting it? We have the first option, 85.0 meters per second, 17.0 meters per second, option B. Option C, 8.5 meters per second. Option D, 1.7 meters per second. Okay, now the distance on the velocity time graph is the area of the shape that you have on the graph. Are you getting it? So that means if I can get the area of this shape, I can get the distance. But don't forget, we are asked to calculate the velocity, and velocity is equals to displacement all over time. Are you getting it? So the distance that we are talking about here is a displacement. So we first need to get the distance from this graph. So that's what I'm going to do. By the way, what is the shape of the graph that you have on the board? It is trapezium, right? So that means if you can know the area of trapezium is equals to a plus b multiplied by h all over 2. Are you getting it? Or 1 over 2 a plus b times h. So that means the distance is equals to 1 over 2 multiplied by a is the parallel sides. Are you getting it? And the first parallel side is the distance from this point to this point. And if you trace it downward, you will discover that it is 8 minus 2. That is 6. Are you getting it? The distance from this point to this point is 8 minus 2. That is what? 6. So I'm going to have 6 plus b. B is the second parallel side of the trapezium. In fact, let me draw it out. This is what we have, okay? The distance from this point to this point is what? 10. I'm going to have 10 here. But if you check the distance from this point to this point, if you trace it downward, you're going to land you're going to discover that you're going to have 8 here. Also, you're going to discover that you're going to have 2 here. So the distance will be the difference between 8 and 2. So I'm going to have 6. Do you understand? So the height, which is h, is the maximum velocity attained. Are you getting it? And if you check the graph, oh, in fact, I didn't put 10. Sorry. I'm coming. I didn't put 10 here. Meter per second. The maximum velocity attained is 10. We have 0, 0, 2, 4, 6, 8, 10. Are you getting it? So now the maximum velocity that it attains is what? Is 10. So that means the h is 10. So I'm going to have here 6 plus 10 multiplied by 10. Do you understand? S is equals to 6 plus 10, 16. 16 over 2 multiplied by 10. Okay, 2 here 1, 2 here 5. 5 times 16 is 80. So the total distance traveled by the object is what? 80 meter. Okay, now we can easily calculate the velocity. Velocity is equals to displacement. Displacement is what? 80. So I'm going to have 80 meter all over time. The time that we are given in the question is what? Is 10 seconds. Okay, from this point, this is the starting point. This is the last point. Are you getting it? So if you look here, is 0. That is the initial time. The final time taken is 10 seconds. So I'm going to have this all over 10 seconds. So the velocity here will be 8 meter per second. Okay, so let us check the correct option. Unfortunately, for this question, there is no correct option. So that is it. Most of the Jamb question, not most actually, some of the Jamb question, you might not find correct option in your option. Just ensure that you know what you are doing. Okay, so the solution to this is 8 meter per second. Okay, a small metal ball is thrown vertically upwards from the top of a tower with an initial velocity of 20 meter per second. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower. A 60 meter, B 80 meter, C 100 meter, D 120 meter. Take G equals to 10 meter per second squared. Okay, let's start by writing out the parameters. We are given that, in fact, let me draw it out. A small metal ball is thrown vertically upwards from the top of the tower. Now, let's say this is the tower. Are you getting it? This is the tower. Now, the ball is thrown upward from this tower. And the velocity with which the ball was thrown up is 20 meters per second. So, the initial velocity U equals to 20 meters per second. Are you getting it? Now, the ball took a total of 6 seconds to reach the ground level. That means as the ball was thrown up, you understand, it got to an height and then it comes down. Are you getting it? Let's say, as I'm holding this marker now, are you getting it? I throw this marker up. Are you getting it? The marker will get to a point, then it comes down. The total time taken for the marker to go up and down for the ball here, relative, okay, let's compare it with the ball. That is 6 seconds. So the time taken, 6 seconds. Total time taken. Let me represent as capital letter T. Are you getting it? So that you will not get confused. Total time taken. That is the time taken for the ball to go up when it was thrown up and come down. Okay. Now, we are asked to determine the height of the tower. So we are looking for H, the height of the tower. Now, please pay attention. The height of the tower will be, okay, let us first get the time taken for the ball to move from this point, to this point. Are you getting it? Let us first determine the time taken for the ball to move from this point to this point. Okay, so I'm going to make use of the first equation of motion, that is V equals to U plus AT. Don't forget that A equals to what? 10 meter, or G, sorry, G equals to 10 meter per second squared. Are you getting it? So because we are dealing with motion under gravity, this will be what? U plus GT. Now, because the ball, when it was thrown up, it is moving against gravity, the G that we're going to have here will be what? Negative. So I'm going to have negative G minus GT. Do you understand? Okay. The initial velocity is 20. Are you getting it? Minus 10 multiplied by t. The final velocity will be 0. Do you know why? Because the ball was thrown up with an initial velocity of 20 meters per second. Now, the final velocity is 0. That is why it would come down. When it gets to the top, the final velocity is 0. It will no longer move forward. The final velocity at that peak is 0. Do you understand? Okay, so you can get the value of t. I'm going to have negative 20 is equals to negative 10t. This over negative 10 and this over negative 10. So t will be equals to 2 seconds. Okay, so the time it takes the ball to move from this point, from the top of the tower to the highest peak here, is 2 seconds. Are you getting it? We can calculate the distance that the ball covers when it was thrown up. Are you getting it? That is the distance that the ball covers when it moves from this point to this peak. Because now we know the time it takes to cover the distance. So we're going to make use of this formula. H equals to ut plus 1 over 2 gt squared. Okay, don't forget that the value of g depends on the direction of the ball. Now, because the ball is being thrown up, that means it is moving against gravity, right? So that means the value of g will be negative. Okay, so for this I'm going to have h1. Let's represent as h1. H1 is the height that the ball covers when it was thrown up. Are you getting it? So h1 is equals to ut. U is what? 20 meters per second. So I'm going to have 20 times t. The value of t will now be 2. Okay, so times 2, 20 times 2 minus 1 over 2 times 10 times 2 squared. You know the reason why I have negative sign here? Because the gravity, the acceleration due to gravity now will be negative. Are you getting it? So if you have plus 1 times minus 10, it will still give me minus. So that's why I put minus here. Minus. So here I'm going to have the height equals to 40 minus 10 times 4 all over 2. The height is equals to 40 minus 40 all over 2. That is 40 minus 20. That is what? 20 meters. So the distance that the ball covered when it was thrown up is what? 20 meters. Okay, having gotten the distance, we can now get the distance it takes for the ball to come down. Do you understand? And the difference between this distance will give us the distance of the tower. Are you getting it? It will give us the height of the tower. So now, don't forget that the total time taken for the balls to go up and come down is what? 6 seconds. The total time taken is 6 seconds. So, and we know that the time taken for the ball to go up when it was thrown up is what? 2 seconds. Are you getting it? From our previous calculation. So that means that I'm going to have 2 seconds plus the t2, which is the time taken for the ball to come down. So t is 6 seconds. 2 seconds plus t2. So t2 is equals to 6 seconds minus 2 seconds. So t2 equals to what? 4 seconds. That is the time taken for the ball to come down. Okay? If you didn't understand, listen to the explanation again. From the question, we are given that the ball was thrown up and the time taken for the ball to go up and come down is 6 seconds. That means this 2 seconds is also part of the 6 seconds. Are you getting it? Now, since we know the time taken for the ball to go up, we can easily get the time taken for the ball to come down by subtracting 2 from 6. Are you getting it? So that's why I have 4 seconds, which is the time taken for the ball to come down. Why do I need to get it? That is the time that I'm going to use to calculate the height that the ball covered when it was coming down. Are you getting it? So I'm going to erase this now. We are still going to make use of the same formula. So for this, I'm going to have h2, which is the height that the ball covered when it was coming down. h2 is equals to ut. Now u will be 0. Are you getting it? The initial velocity will be 0. When the ball was thrown up, it attains the velocity, right? That is final velocity for when it was going up. For when it was going up, that is the final velocity. Now, the ball is coming down. That final velocity will become the initial velocity. That means that u will be 0. Do you understand? Okay, so I'm going to have 0 multiplied by the time. The time is now 4 seconds. So I'm going to have 0 times 4. Now, because the ball is coming down, it is moving towards gravity. So I'm going to have positive. The acceleration due to gravity will be positive. So I'm going to have plus 1 over 2 multiplied by g. G is now 10. So I'm going to have times 10 times 4 squared. Okay. So H2 is equals to, this times 0 will be 0. I'm going to have 10 times 4 squared. 4 squared is 16. So I'm going to have times 16 all over 2. H2 is equals to 160 all over 2. That is 80 meter. Okay. Now, to get the height of the tower, we know that the height, please pay attention, G equals to 10 meter per second squared. The height from this point to this point is what? Is 80 meter. And the height from this point to this point is 20 meter. Now, the distance of the tower, which is the distance from this point to this point, will be the difference between this and this. Are you getting it? So I'm going to have the height of the tower. The height of the tower will be equals to 80 meter minus 60, minus 20 meter. That is what? 60 meter. The distance of the tower is 60 meter. Do you understand? The correct option to that question is option A. Option A is correct. Okay? Let us proceed to the next question. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? Okay? Please pay attention to that question. Let me erase this now. Let's start by writing out the information that we are given in the question. The body starts from rest simply means the initial velocity is 0. So U is equals to 0. The uniform acceleration that the body moves with is what? 6 meters per second squared. So A is equals to 6 meters per second squared. Okay? We are looking for the distance. So the distance that is covered in the third seconds. Okay? S3. Now listen to me carefully. The distance that the body covers in the third second will be the difference between the distance S is equals to S3 minus S2. That is what I'm trying to say. The distance that the body covers in the third second simply means the distance that the body covers in the last 1 second. Are you getting it? Now, that will be the difference between S3 and S2. So that means that you have to calculate S3 differently, S2 differently. Then you take the difference, okay? Now, from the information that we're given in the question, which formula are you going to use to calculate the distance? Well, it's simple. Since you know that A equals to 6 meters per second squared, you can easily get the velocity, okay? Velocity, V, is equals to acceleration multiplied by time. Do you understand? Okay. V equals to acceleration, which is 6 times t. Now, when the time is 2 seconds, you're going to have 6 times 2. That is what? 12 meters per second. Now, V equals to 6 times 3. That is when the time is in 3 seconds. That is what? 18 meters per second. Okay. Now, you can get the distance by making use of S equals to ut plus 1 over 2 at squared, okay, or V squared equals to u squared plus 2as, okay. V squared equals to u squared plus 2as. Are you getting it? So now for S3, V is what? V is 18 meters per second. So I'm going to have 18 squared is equals to u is 0. So that will be 0 squared. 0 squared is 0 plus 2 multiplied by A. A is 10. So I'm going to have 18 squared is 3, I'm coming, 324. So I'm going to have 324 equals to 20s. This over 20. No, sorry, A is 6 meters. So, sorry, A is 6. So that will be 12. This over 12, 12 seconds. This over 12, and this over 12. That means S3 is equals to, that is 27 meter, okay? Now, we need to get the value of S2 as well. That is when the time is 2 seconds. So, I'm going to have for S2, t equals to 2, okay? And the velocity is equals to what? 12 meters per second. So I'm going to have v equals to 12. So using this formula as well, I'm going to have 12 squared. 12 squared is equals to u squared, which is what? 0 plus 2a s. Are you getting it? So that is 144 equals to 12 multiplied by s, okay? Because 6 times 2 will give you 12. Divide this by 12, this over 12 and this over 12. S2 is equals to 12 meter, okay? Now we can get the value of the distance that the body covered in the 30 seconds, okay? Just take the difference between S3 and S2. So the distance that I'm looking for, S is equals to S2, S3. S3 is 27 meters, so I'm going to have 27 meter minus S2, which is 12 meter. So S is equals to 15 meter. So let us check the correct option for the question. Option A, we have 15, option B, 18, option C, 27, option D, 30 meter. The correct option is option A. Option A is correct. Okay? Do you understand the solution? It's simple. Honestly, it's simple. You see, I am given the acceleration. I'm looking for the distance in the 3rd second. Because the body starts from rest, the initial velocity will be 0. Do you understand? The distance that the body covered in the 3rd seconds will be the difference between the distance when the time is 3 seconds and when the time is 2 seconds. So, and because I'm not given the velocity, so I have to calculate the velocity. And because I know that acceleration is equals to change in velocity over time, acceleration A is equals to V. In fact, let me write A equals to V over T. That means that V will be equals to A times T, right? Now, acceleration is 6 meters per second squared, but the time change. You understand? When the time is 2 seconds, the velocity will be what? Acceleration times 2 seconds. That is what? 12 meters per second. When the time is 3 seconds, the velocity will be acceleration, which is 6 times 3. That is 18 meters per second. Okay. Now, having gotten the velocity, I make use of the 3rd equation of motion, which is v squared equals to u squared plus 2as, to get the value of the distance respectively when the time is 3 and when the time is 2. Are you getting it? So having gotten the distance, I take the difference to get the value of the distance that the car covered in the 3rd seconds. Okay, so that is the solution to that question. Let's look at more work question on this topic: linear motion and projectiles. A stone Q is thrown with velocity at an angle of 75 degrees to the horizontal. Another stone R is thrown with the same velocity but at an angle of 15 degrees to the horizontal. The ranges covered by the stones will be A greater for Q, B greater for R, C the same for Q and R, D greater for the area of the stones. Okay? Now, this question, I'm going to show you the calculation. Do you know that in projectiles, range, oh God, let me erase this now. Let me erase this. Let me erase. Range is equals to u squared sine 2 theta all over g. Are you getting it? This is the formula for calculating to calculate the range of a projectile's motion. Are you getting it? An object that is projected. Now, we are given that we have 2 objects. The first object is the object Q. The range of Q will be equals to u squared sine 2 theta. Theta is what? 75 degrees for Q. Listen to me carefully. Theta is 75 degrees for Q. Let me check. Yes. And also this all over G. And for R, for object R, the range of R will be equals to u squared sine 2 multiplied by 15 degree all over G. Now listen to me carefully. Do you know that sine 2 times 75 degrees will give me what? 150, right? Sine 150 is equals to 0.5. Are you getting it? Sine 150. Sine 150 degree is equals to 0.5. And also, sine 2 times 15 degree will be sine 30. Sine 30, sine 30 degree is equals to 0.5 as well. That should tell you that means the range of both Q and R will be the same. Are you getting it? Because the angle of projection, even though they differ, based on quadrants, they are still the same. Do you understand? Okay, so that is the solution to that question. The correct option to that question is option C. The range will be the same because the value of theta, listen, U is the same, U is the same, G is the same, G is the same. The only parameter that could make the range differ is the angle of projection. Now, because the angle for theta for object Q is what? 75 degree. For object R is 15 degree. When you point this in your calculator, you're going to obtain 0.5. And if you input some real value in both formula, you're going to arrive at the same answer. That means their range are the same. Do you understand? So the correct option is option C. The range will be the same for both R and Q. Okay? So let us proceed to the next question. The diagram above shows a velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and the retardation periods of the motion. A 75 meter, B 150 meter, C 300 meter, D 375 meter. Okay, before you can answer that question, you have to know the phase. You have to know the phase whereby the object is undergoing acceleration and retardation respectively. Okay, now in this on this velocity time graph, we have three phases. Are you getting it? The first phase is acceleration phase, and the phase is from this point to this point. Are you getting it? Acceleration phase, because you can see that the velocity, this is velocity and this is the time. The velocity changes, it increases from 0 and then it attains the velocity of 10. Are you getting it? Now, having gotten to the velocity of 10, it maintains a constant velocity. Are you getting it? The velocity is constant here. So that means the second stage, the velocity is constant. Here is acceleration. Here, A equals to 0. There is no change in acceleration. Now, here, the acceleration decreases. That is retardation, okay? So here we have retardation. So that means since the area of the shape on the velocity time graph tells us the distance traveled by an object, that means if I can get the area of this shape, the first phase is this. And the area of the retardation phase, which is the second phase. The area of the acceleration phase is right angle triangle, you know. The area of the retardation phase as well is a right angle triangle. So that means this is 0, this is 10. You can see that the distance from this point to this point is what? Is 10. Are you getting it? So that means that this also will be 10. Okay. Now, the distance from this point to this point as well is 10. So I'm going to have 10 here. Now, listen to me carefully. If the distance from this point to this point is 50, that means from this point to this point is what? Is 45. Are you getting it? So I'm going to have, if you want to get the distance from this point to this point, that is 45 minus 40. What's the answer? 5. So I'm going to have 5 here. Okay? Here will be 10. Because from 0 to 10, are you getting it? 0 to 10 simply means, assuming we have a significant number here, we are going to take the difference between 10 and the number. 10 minus 0 is what? 10. So I'm going to have 10 here. And also the distance from this point will be what? 10 as well. So let me just draw the diagram like that. Now, let us calculate the area of both triangle, then add them together, okay? Let's start with the acceleration. Let me call the acceleration S1. And, okay, let's call it A1. A1 and the retardation A2, okay? Area of the first triangle A1 equals to half base times height, 1 over 2 times the base is 10. So I'm going to have times 10 times 10, okay? And for the A2, I'm going to have 1 over 2 multiplied by 5 times 10, okay? So 10 times 10 is 100, right? 100 all over 2, that is 50 meter. That is the distance for the first, for the acceleration phase, the distance is 50 meter. For the retardation phase, you're going to have 50 all over 2, that is 25 meter. For the retardation phase, the distance is 25 meters. So we need to sum the distance together. Here, I'm going to have 50 meter plus 25 meter. That is 75 meter. Do you understand? Okay. So the total distance traveled by the car during the acceleration and the retardation phase is 75 meter. And the correct option to that question is option A. Option A is correct. Do you understand? Okay, let's proceed to the next question. An aeroplane lands on a runway at a speed of 180 km per hour and is brought to a stop uniformly in 30 seconds. What distance does it cover on the runway before coming to rest? A. 360 meter, B. 540 meter, C. 750 meter, D. 957 meter. Okay, let's start by writing out the information that were given in the question. An aeroplane lands on a runway at a speed of 180 km per hour. That should tell you that the speed at which the aeroplane was moving is what? 180 km per hour. That will tell, and that will be the initial velocity. Do you understand? So the initial velocity u equals to 180 km per hour. Okay, and is brought to stop uniformly in 30 seconds. So the time taken is what? 30 seconds. What is the distance? What distance does this cover in the runway? Okay, we are looking for the distance. S is unknown. Okay, now listen. The first thing is that the final velocity will be what? 0. Are you getting it? So I'm going to have V equals to 0. Okay, now having understand that V equals to 0, you go back to this and then change this to meter. Okay, 180 kilometer 180 kilometer per hour. Change it to, you're going to have 180 times 1000 all over 60 times 60, right? You want to change this to meter per seconds, okay? So 180 times 1000, that is 18,000. Oh, 180,000. 180,000 all over 3,600, okay? Yes. This will cancel this. This will cancel this. 1,800 divided by 36, that is 50. So here I'm going to have 50 meter per second. Okay, now, so this is 50 meter per second. Now, we are looking for the distance with respect to the parameters that we have here. Which of the equation of motion are we going to use? We are going to make use of S equals to ut plus 1 over 2 at squared. If you want to make use of this, you don't know the acceleration, do you know? And the acceleration can be gotten. Acceleration is equals to velocity, change in velocity, that is what? V minus u all over t. A equals to negative u all over t, right? Because the velocity is the final velocity is 0. So acceleration equals to minus u negative 50 all over the time taken. The time is 30, so I'm going to add all over 30. Acceleration equals to negative 5 all over 3. Okay, the reason why we have negative is because the aeroplane is coming to an rest. It's coming to rest. Are you getting it? Hello? This acceleration is retardation. Are you getting it? And that is the kind of acceleration that brings the motion of an object to rest. So that is why we have negative sign. So for this, I'm going to have S, which is the distance, equals to ut, that is 50 multiplied by the time taken, that is 30, plus 1 over 2 multiplied by the acceleration, which is negative 5 all over 3 multiplied by t squared. T is 30, so I'm going to have 30 squared. Let me erase this. Let me erase this now. So that is 30 squared. Okay. 1,500 minus, okay, 30 squared is 900. So I'm going to have minus 5 times 900 all over 6, okay? S is equals to 1,500 minus 900 times 5. That is 4,500 all over 6, okay? S is equals to 1,500 minus. This divided by 6 will give me 750. So I'm going to have 750 here. S is equals to 750 meter, okay? So the distance that the aeroplane covered when it landed with an initial velocity of 180 km per hour is 750 meter. Do you understand? And also, you can make use of this formula. S is equals to V plus U multiplied by T all over 2, okay? You can make use of this formula if you don't want to use this formula, okay? That is why I said you should master all the 4 equations of motion. That one that I wrote on the board the other time, okay? So let's look at the next question here. The correct option to that question is option C, okay? Option C is correct. An object is projected with velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is A 20 meter, B 8 meter, C 160 meter, D 320 meter. Okay, please kindly pay attention. Let me quickly erase this. Now, the initial velocity which the object was projected with is what? 80 meters per second, right? So that means I'm going to have U equals to 80 meters per second, okay? The angle of projection to the horizontal is 30 degrees. So that will be theta equals to 30 degrees. Are you getting it? Okay. We are asked to calculate the maximum height. We are looking for the value of h. A projected object always have 3 properties. Number 1, the time of flight, the range, and also the maximum height attained. Now, the formula for the maximum height is this: u squared sine square theta all over 2g. Are you getting it? Now, u is 80, so I'm going to have height is equals to 80 squared multiplied by, don't forget that sine square theta, listen, sine square theta is equals to sine theta raised to the power of 2. Are you getting it? So I'm going to have sine 30 degree raised to the power of 2 all over 2 multiplied by g. G is positive. Acceleration due to gravity, that is what? 10. So I'm going to have 2 times 10. Okay? H is equals to 6,400 multiplied by sine 30 is 0.5. Yes. Or that is 1 over 2. 1 over 2 raised to the power of 2 all over 20. Okay? The height which the object attained is 6,400 multiplied by 1 over 4. This over 20. H is equals to 4 here 1. 4 in 64, that is 16, right? So I'm going to have 16 here, 1,600. 1,600 divided by 20. So 160 all over 20, that is 80. So the correct option to that question is option B, which is 80 meter. Do you understand? Okay. You see, let me tell you, there are 3 important formulas in projectiles: time of flight, maximum height, and the range. Okay, so please make sure you master them. If you want to learn more on projectiles, you can check the link in the description of this video. Okay, now let's look at the next question. A motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. Calculate its retardation. Okay, the vehicle is moving with a speed of 15 meters per second before. That means that the initial velocity is what? 15 meters per second. 15 meters per second. That is the initial velocity. And the time is equals to 20 seconds. Now, we want to find the retardation. retardation is negative acceleration. Are you getting it? So to get the retardation, all you have to do here, don't forget that acceleration is equals to change in velocity all over change in time, right? So acceleration is equals to, now the velocity v will be equals to 0. Are you getting it? So I'm going to have here 0 minus 15 all over 20. Are you getting it? So here, acceleration will be negative 15 all over 20. Acceleration equals to minus 3 all over 4. Okay? Negative 3, yes, negative 3 divided by 4, that is 0.75. So A equals to negative 0.75. Okay? So the correct option to that question is option A. Are you getting it? Option A is correct for that option, for that question. When a ball rolls on a smooth level ground, the motion of its center is A. Translational motion, B. Oscillatory motion, C. Random motion, D. Rotational motion. Okay, let's say we have a ball here and it's rolled on this ground. The direction is this, right? Are you getting it? The ball will roll like this. Now, if you look at the center here, the motion will be what? Is rotational. Are you getting what I'm trying to say? Is in circular form. So therefore, the correct option is option D. Okay? Are you getting it? The motion of its center is what we are concerned about now. Are you getting it? So the motion of its center is rotational. Are you getting it? In circular form. Okay? Let's look at the next question. The velocity time graph of a body moving in a straight line and decelerating uniformly to rest is represented by A. We have this diagram. B. We have this diagram. C. We have this velocity time graph. And D. We have this velocity time graph. Which of these velocity time graph indicates an object moving on a straight line and decelerating? This is acceleration. Okay. The correct option is option B. Are you getting it? Because the body here is brought to rest. Are you getting it? Along this along a straight line at time t. So the correct option is option B. The rest. If you choose this is acceleration. You can see how the line goes. Also, this one is also a kind of acceleration, but this one is curve. So the correct option is this. Now, let us look at the next question. The distance x meter traveled by a particle in time t seconds is described by the equation x equals to 10 plus 12t squared. Find the average speed of the particle between the time interval t equals to 2 seconds and t equals to 5 seconds. A. 60 meters per second. B. 72 meters per second. C. 84 meters per second. D. 108 meters per second. Okay? We have this. The distance in meter x is equals to 10 plus 12t squared. Are you getting it? That is the equation that we are given. We are asked to find the average speed when t between the time interval t equals to 2 seconds and t equals to 5 seconds. Now, if you want to calculate the average speed, let us first get the equation for the velocity. Are you getting it? Here, I'm going to make use of differential calculus. Differentiation, I'm going to make use of it here. So first take the first derivative of the displacement function. Are you getting it? So I'm going to have dx all over dt is equals to, if you differentiate a constant, you're going to have 0. If you differentiate 12t squared, you're going to have 2 times 12t raised to the power of 2 minus 1. Okay? You remember this formula. Ax raised to the power of n minus 1 multiplied by n. Are you getting it? So it is that same formula that you make use of here. If you want to learn more on differential calculus, you can check the link in the description of this video, okay? So here I'm going to have dx all over dt is equals to 2 times 12. That is what? 24. That is 24t, because 2 minus 1 is t raised to the power of 1. That is t. T raised to the power of 2 minus 1 will give me t. So that's why I have this. So this function that you have here is the velocity function. V equals to 24t. Okay? Now, to get the average speed, we're going to substitute the value of t we're going to substitute each value of t into this function. So I'm going to have v. Okay, let's continue here. When t equals to 2 seconds, v will be equals to 24 multiplied by 2. That is equals to 48 meter per second. Are you getting it? Okay. What of when t equals to 5 seconds? I'm going to have v is equals to 24t, right? When t equals to 5 seconds, the velocity will be equals to 24 multiplied by 5. Velocity will be equals to 120 meter per second. Okay, let me call this one velocity at 5 seconds. Call this one velocity as 2 seconds. Okay, now to get the average velocity, you have to sum the velocity at 5 seconds and the velocity as 2 seconds. You have to sum them together and divide it by 2. So the average velocity is equals to v2 plus v5 all over 2. Okay, the average velocity will be equals to v2 is 48. I'm going to have 48 plus 120 all over 2. Are you getting it? The answer is 84. The average velocity will be equals to 84 meter per second. Okay, so let us look at the correct option. The correct option to that question is option C. Yes, option C is correct. 84 meter per second. Option C is the correct option. Okay, now let us proceed to the next question here. Two bodies x and y are projected on the same horizontal plane with the same initial speed but at angles 30 degree and 60 degree respectively to the horizontal. Neglecting air resistance, the ratio of the range of x to that of y is A 1:1, B 1:2, C √3:1, D 1:3. Okay, please kindly pay attention. To answer this question, the first step is to remember the formula for range. Are you getting it? The formula for range in projectiles R is equals to U squared sine 2 theta all over G. Are you getting it? This is the range formula. Now, the theta that we are given are 30 degree and 60 degree. Let me call this theta 1. Let's call this theta 2. 30 degree and 60 degree respectively. Okay. Now, this is for x, I think. Okay. Yes, let's call it x. Let's call this one y. Okay. Let's calculate for range of x. Range of x will be equals to U squared sine 2 theta, 2 times 30 degree, right? All over G. And the range of y will be equals to U squared sine 2 multiplied by 60 degree, right? All over G. Okay, now we have to take their ratio, and ratio simply means division. Do you understand? So I'm going to have Rx all over Ry is equals to U squared sine. Now 2 times 30 is what? 60. I'm going to have U squared sine 60 all over G divided by U squared sine 120 degree all over G. Okay, now Rx divided by Ry will be equals to, let me change the marker here because it is fading, U squared sine 60 degree all over G multiplied by G over U squared sine 120 degree. Okay, now based on quadrants, based on quadrants, you know that sine theta, for theta, okay, for 90 degree less than theta less than 180 degree, sine theta is equals to sine 180 minus theta. Are you getting it? So I'm going to use these properties. I'm going to rewrite sine 120 degree as sine 60. Are you getting it? Because now if theta is 120, I'm going to have sine 120 degree equals to sine 180 degree minus 120 degree. Is that not it? That means that sine 120 degree, I'm coming here, sine 120 degree is equals to sine, now 180 degree minus 120 degree, that is 60 degree. So I'm going to replace the value of sine 120 degree as sine 60 degree. Note, this g will cancel this g. Also, u squared will cancel what? U squared. So I'm going to have rx, the ratio of the range of x to that of y will be equals to sine 60 degree divided by, instead of sine 120 degree, I'm going to rewrite it as what? Sine 60 degree. So equals to sine 60 degree. That will be what? Rx all over ry is equals to 1 over 1, which is what? 1:1. So therefore, the correct option to that question is option A. Option A is correct. Do you understand? So that is the solution to that question. Let us proceed to the next question. In free fall, a body of mass 1 kilogram drops from a height of 125 meters from rest in 5 seconds. How long will it take another body of mass 2 kilograms to fall from rest from the same height? They are comparing two scenarios. In this question, we are comparing two scenarios. The first scenario is 1 kilogram body released from rest from an height of 125 meters, and the time taken for it to get to the ground is 5 seconds. Okay, now they now give us another body of 2 kilograms, the same height. Now we are asked to find the time it will take the body to reach the ground. Now the acceleration due to gravity that we are given in the question is 10 meters per second squared. Are you getting it? Now, when we neglect air resistance, are you getting it? The acceleration is not affected by the mass of the object. Are you getting it? Please pay attention. No matter the size of the object, no matter the weight of the object. For example, if you look at the weight of the first object, it is what? 1 kilogram. The weight of the second body is what? 2 kilogram. You know that this 2 kilogram is weightier than that of what? 1 kilogram. But now, the time will also be the same. Do you know why? The acceleration due to gravity does not change. Do you understand? So that means it will also take 5 seconds for the body of 2 kilograms to reach the ground. Are you getting it? I hope you understand. So that, the correct option to that question is option A. Option A is correct. Now, let us look at the next question. The diagram above shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are A, 8 meters per second squared, 4 meters per second squared, B, 4 meters per second squared, 8 meters per second squared, C, 4 meters per second squared, 2 meters per second squared, D, 2 meters per second squared, and 4 meters per second squared. Okay? For the acceleration is equals to velocity change all over change in time, right? So acceleration is equals to, now we know that the body is accelerating from this point to this point, right? So the initial velocity is what? The initial velocity u equals to 0, and the velocity that is attained is what? Is 80 meters per second. So I'm going to have u equals to 0, yv equals to 80 meters per second. Are you getting it? So I can calculate the acceleration as follows. Here I'm going to have v minus u all over t2 minus t1. T1 is the initial time taken, and that is what? 0. T1 equals to 0. T2, which is the final time, is what? 20 seconds. So I'm going to have 20 seconds here. So that will be acceleration equals to 80 minus 0 all over 20 minus 0, right? So A equals to 80 all over 20. A equals to 4 meters per second squared. Okay? Now let us calculate for retardation as well. For the retardation, you can see that, listen to me carefully. Retardation starts from here because when the body accelerates, it attains a velocity which is what? 80 meters per second, right? Now, it maintains that velocity for this time range. It maintains that velocity for this time range. Now, when it got here, you can see that the velocity begins to decrease. It is no longer acceleration, it is decelerating. Are you getting it? So this velocity itself, the velocity that it attains here will be u for the third phase of the motion. Are you getting it? Don't forget I told you we have three phases here: acceleration, constant, and we have retardation. So u here will be 80 meter per second. Are you getting it? And the final velocity, which is the velocity when the body or the vehicle is not moving again, will be what? 0. So v equals to 0 meter per second. Okay, so we can calculate the retardation and the time taken. This is for acceleration, don't forget. For retardation, r is equals to, it's still the same formula. Okay, let us get the parameters. U equals to 80 meter per second for the retardation, and v equals to 0 meter per second. T1 is equals to the time is what? 50 at this point. Trace it to the time. The time is 50. So I'm going to have T1 equals to 50 seconds. And T2, when the body is no longer moving, is what? 90. So T2 is equals to 90 seconds. Okay. So we can calculate the retardation as follows. Retardation is equals to V minus U, 0 minus 80. Are you getting it? All over T2, which is 90 minus 50. Okay. So retardation is equals to negative 80 all over 40. R is equals to negative 2. Okay, R equals to negative 2 meter per second. So the deceleration, now listen to me carefully. You can ignore the negative sign. Are you getting it? Ignore the negative sign now. The negative sign is just to tell us that the body is decelerating. Are you getting it? Because here we have negative acceleration. So the retardation is equals to 2 meter per second squared. Oh, sorry. Square is supposed to be there. So the acceleration is 4 meter per second squared, while the retardation is 2 meter per second squared. The correct option to that question is option C. Option C is correct. Okay. If you have any question, you can let me know in the comment section. Okay. Let us proceed to the next question. The velocity v of a particle in a time is given by the equation v equals to 10 plus t squared. Find the instantaneous acceleration after 5 seconds. Now, instantaneous acceleration is the acceleration of a body at an instant of time. Are you getting it? I'm going to explain. Just pay attention. Okay, let me erase this now. When we talk about instantaneous acceleration, the acceleration of a body at a particular time, at a particular seconds, is called instantaneous. Now, we are given the velocity function. The velocity function v is equals to 10 plus 2t squared, right? And we are asked to find the instantaneous acceleration, instantaneous, at 5 seconds. At 5 seconds. Now, we first have to get the acceleration function. Are you getting it? Since you know that acceleration tells us how fast the velocity of an object is changing. So, acceleration is equals to dv all over dt, calculus. If you differentiate 10, you're going to have 0. If you differentiate 2t squared, what are you going to have? 40, right? So I'm going to have 40. That means the acceleration function is equals to 40. The instantaneous acceleration at t equals to 5 seconds will be equals to a equals to 4 multiplied by 5. 4 times 5 is 20. So that will be what? 20 meter per second squared. Okay? So the correct option to that question is option C. Yes, option C is correct. Okay? A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that has just turned red. If he just reached the traffic light, his deceleration is A, 5 meters per second, B, 9 meters per second squared. Okay, let me dictate the question again. Let's take it again. A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that has just turned red. If he just reached the traffic light, his deceleration is A, 5 meters per second squared, B, 9 meters per second squared, C, 10 meters per second squared, D, 18 meters per second squared. Okay, now look, pay attention. The motorcyclist was traveling at a speed before, and that speed is 30 meters per second. That means the initial velocity is equals to 30 meters per second, okay? The final velocity will be equals to 0, okay? And the distance that it covers when it applies the brake is what? 50 meters. So S equals to 50. Our goal is to find the value of the deceleration. We are looking for the negative acceleration. Now, how can we get the acceleration based on the parameters that we are given? You can do this in your way, but just make sure that you know what you are doing. You can get the time, are you getting it, and make use of S equals to ut plus 1 over 2 at squared. And you can also make use of this formula, v squared is equals to u squared plus 2as. Are you getting it? So I'm going to have v squared, v is 0, 0 is equals to 30 squared, pay attention here, plus 2 multiplied by a multiplied by s. The s is 50, so I'm going to replace as 50 here. 50, sorry. 50. So here I'm going to have 0 equals to 900 plus 100 times a. Are you getting it? So negative 900 is equals to 100a. Divide by 100, this over 100 and this over 100. A equals to negative 9 meters per second squared. So the deceleration is equals to 9 meters per second squared. The reason why we have negative sign is because the motion of the body is reducing. Are you getting it? The speed is reduced. The acceleration is negative acceleration. Are you getting it? That is deceleration. So the correct option to that question is option B, 9 meters per second squared. Option B is correct. Okay. Let's look at the next question. The motion of a smoke particles from a chimney is typically a oscillatory motion, B, rotational motion, C, circular motion, D, random motion. Okay. Have you seen a smoke before? The motion is random. Are you getting it? The motion is not in circular form, so we cannot call it rotational motion. The motion is random. It doesn't have a particular direction. It doesn't follow a pattern. Are you getting it? So the correct option to that question is option D is correct. For that question, option D is the correct option. Okay. Let us proceed to the next question. A shooter wants to fire a bullet in such a way that its horizontal range is equals to 3 times its maximum height. At what angle should he fire the bullet to achieve this? Wow, what a beautiful question. This question is from projectiles, okay? So now, what is the angle that the shooters must fire the bullet in such a way that the range will be 3 times the maximum height? The first step is that you have to bring out the formula for range. Are you getting it? Yes. Range is equals to u squared sine 2 theta all over g. Are you getting it? And height is equals to u squared sine square theta all over 2g. This is the formula for range and height of a projectile object respectively. Okay. U squared, please pay attention. U squared sine 2 theta all over g. Don't forget our goals. Our goals is to find the value of theta that will make r equals to 3 times h. Are you getting it? Because from the question, we want to find the angle at which the shooter must fire so that the horizontal range will be 3 times. Are you getting it? 3 times the maximum height. So I'm going to have, at what value will this be equals to 3 multiplied by u squared sine square theta all over 2g. Now, when you equate this to this, the next step is that you have to simplify it. Are you getting it? So I'm going to have u squared sine 2 theta all over g equals to 3u squared sine square theta all over 2g. Are you getting it? So I'm going to cross multiply. For this, I'm going to have 2g u squared sine 2 theta equals to 3g u squared sine squared theta. Hello, are you getting what I'm doing? Now, divide both sides by g. This over g and this over g. So, I'm going to have this. And we left with what? 2u squared sine 2 theta equals to 3u squared sine squared theta. In fact, we can still divide by u squared. So, I'm going to have this over u squared and this all over u squared. So, please pay attention. It's simple, okay? Let me erase this. So, I'm going to have here 2 sine 2 theta equals to 3 sine square theta. Okay, now don't forget that trigonometry. From trigonometry, you can rewrite sine 2 theta as 2 sine theta cos theta. Are you getting it? It's an identity in trigonometry. So I'm going to replace sine 2 theta as 2 sine theta cos theta. So here I'm going to have 2 multiplied by 2 sine theta cos theta equals to 3 sine square theta. So for this, I'm going to have 4 sine theta cos theta equals to 3 sine square theta. The next step here is that I'm going to divide by sine square theta. And this over sine square theta. So I'm going to have 4 sine theta cos theta all over sine square theta equals to 3 sine. Okay, this will eliminate this. So I'm left with what? 3. 3 over 1. Okay, having gotten to this point, the next step is that I'm still going to divide both by 4. So this over 4 and this also multiplied by 1 over 4. So this 4 will eliminate this 4. So I'm going to have sine theta cos theta all over. Now, sine square theta can be written as what? Sine theta sine theta. Are you getting it? Sine theta times sine theta will give me sine square theta. So here I'm going to have this equals to 3 over 4. You are still not done. You can see that. You see, let me tell you, if you are dealing with this question in exam, you don't have to go through all these steps. You understand? The reason why I go through all these steps is because I'm explaining. Okay? So if you are dealing with it in the exam, you can just eliminate and cancel everything out, and then you're going to have 3 over 4, and then from trigonometric identity, you find the value of arctan, because that is where we are going to resort to. So just pay attention. It's simple. Aha. Now, when you get to this point, sine theta, we eliminate sine theta. So I'm going to have cos theta over sine theta is equals to 3 over 4. Now, don't forget that tan theta is equals to sine theta over cos theta. That means the inverse of tan theta will give me the inverse 1 over tan theta will be equals to cos theta all over sine theta. Do you understand? Hello? If you don't understand, listen to the explanation again. Tan theta is sine theta over cos theta from trigonometric identity. Now, I'm having cos theta over sine theta. That means the inverse of tan theta. Inverse simply means the reciprocal. You understand? The reciprocal of tan theta will give me cos theta over sine theta. So instead of cos theta over sine theta here, I'm going to replace it as what? 1 over tan theta. So I'm going to have 1 over tan theta is equals to 3 over 4. Cross multiply. 3 tan theta is equals to, yes, is equals to 4. Divide both by 3. This over 3 and this over 3. That will give me tan theta is equals to 4 over 3. Theta is equals to the tan inverse arctan 4 over 3. What is 4 divided by 3? Point your calculator. 4 divided by 3. That is 1.33. Theta equals to the tan inverse of 1.3333. Okay? Let us take the tan inverse. I'm coming up. 1.333. That is 53. Theta equals to 53.129 degree. Theta is equals to 53 degree. Okay. So the correct option to that question is option A. Option A is correct. So option A is the correct option. Do you understand? So that is the solution to that question. Let us look at the next question. Acceleration between 2 points on a velocity time graph which has coordinates 10 seconds, 15 meter per second and 20 seconds, 35 meter per second. Okay, we are asked to find the acceleration. Now listen. Acceleration tells us how fast the velocity of an object is changing, right? So acceleration is equals to change in velocity all over time. So I'm going to have acceleration equals to dv all over dt. And the point that we are given, the first point, let me call it point x. The first point is 10 seconds, 15 meter per second. Are you getting it? And the second point, let us call it point y, is 20 seconds, 35 meter per second. Okay? So, based on this, you know, from coordinate geometry, the formula for gradient is what? Change, rise all over run. Are you getting it? The vertical change all over the horizontal change. Are you getting it? So, and you know that it is velocity that is always on the vertical, on the velocity time graph. Do you know? And the acceleration is, and the time is always on the horizontal. This is what I mean. If you want to draw the diagram for this now, you're going to have 35 meter here, meter per second here, 15 meter per second here. Are you getting it? And this will be 0. And this will be 10 seconds. And this will be what? 20 seconds. Now, if you want to calculate the gradient, oh, sorry. This will be 20 seconds. I just sketch it out. You understand? The gradient will be change in y. Sorry, please. I want to understand, okay? I just want to sketch it out, and this is it. I want to sketch this out now. Let me put the 20 seconds here. The gradient will be change in v all over change in what? Change in t. You understand? dv all over dt will give us the gradient. Now, what is the formula for this? Acceleration, right? So that means if you can calculate the gradient of the point, you're going to get the acceleration. So this will be what? X1, y1, x2, y2. The formula for slope or gradient is equals to y2 minus y1 all over x2 minus x1. So the acceleration is equals to y2, which is 35 minus 15 all over x2. x2 is 20. 20 minus 10. Acceleration is equals to 35 minus 15 is what? 20. 20 all over 20 minus 10 is 10. So acceleration is equals to 2 meter per second squared. And the correct option to that question is option D. Option D is correct, 2 meter per second squared. Okay? Let us proceed to the next question. A car accelerates uniformly from rest at 4 meter per second squared. How far will it travel in the 5th complete second? A, 100 meter, B, 50 meter, C, 32 meter, D, 18 meter. Okay, please kindly pay attention. We are given that the car accelerates from rest. That means the initial velocity of the car is equal to 0. Are you getting it? And the acceleration is equal to 4 meter per second squared. Okay? Now, how far will it travel simply means we are looking for the distance, right? So we are looking for S. S is unknown. Now, if the initial velocity is equal to 0, S is what you are looking for. Now, notice this word, fifth, F-I-F-T-H. Fifth simply means the distance the car covers between the time t equals to 4 seconds and the time t equals to 5 seconds. Please pay attention to the details of the question. The word fifth simply means the distance that the car cover between the time when we have t equals to 4 seconds and t equals to 5 seconds. Are you getting it? And if you check the question very well, you will discover that they said calculate the distance it travel in the 5th complete second. That is singular. Are you getting it? So that means we are looking for the distance for 1 second, and that will be what? And the distance S5 minus S4. S5 is when t equals to 5 seconds, and S4 is when t equals to 4 seconds. Okay, let's proceed with our calculation. We're going to make use of this formula: v squared equals to u squared plus 2as. Are you getting it? But here we don't know the value of v. Hello? We don't know the value of v, right? So can we make use of this? No. What of this? S equals to ut plus 1 over 2 at squared. We can make use of this because we have u, we have a, we have t, which is 5 seconds and 4 seconds respectively. So let us proceed. Here I'm going to have S5 equals to, now u is 0. That means that t here will be also 0. So I'm going to have 1 over 2 times 4 multiplied by t squared. Here t equals to what? 5. So I'm going to have 5 squared. S5 is equals to 4 multiplied by 25 all over 2. The distance that is covered in the 5th second is 100 all over 2, which is what? 50 meters. Okay, let us calculate the distance that the car covers in 4 seconds. When t equals to 4, I'm going to have S equals to at squared all over 2. S equals to 4 multiplied by t squared. That is 4 squared, right? All over 2. S4 is equals to, now 4 squared is 16. 16 times 4 is 64, right? So I'm going to have 64 all over 2. That is what? 32 meters. Okay. So the distance that is covered is the difference between 50 and 32. So S is equals to 50 meters minus 32 meters. That is 18 meters. Are you getting it? So the answer to the question is, the correct option is option D. Okay. Yes, the correct option is option D. Okay. Now let us proceed to the next question. The diagram above shows a velocity time graph. The statement that is true about this motion is that the car A decelerates between point F and H, B accelerates between point F and G, C has a constant speed between point E and F, D has no acceleration between point F and G. Okay, now on this velocity time graph, we have 3 phases. The first phase is the acceleration phase. Hello? The first phase is the acceleration phase. E to F, the car accelerates. Are you getting it? It accelerates from E to F. Are you getting it? Now, F to G, the velocity, the acceleration of the car is constant. You understand? Acceleration is constant. Okay, and from G to H, the car decelerates. You understand? Decelerates. The car decelerates from G to F. Okay, that is the summary of the velocity time graph that we have on the board. Okay, so now based on what I summarized here, which of the option is correct? You will discover that option D is the option D now. Option D says has no acceleration between point F and G. You can see that the acceleration is not changing. That is why you can see a straight line. Are you getting it? Straight line on a velocity time graph indicate that the acceleration is not changing. That is, the acceleration is constant. Okay, so the correct option is option D. Okay, option D is correct for that question. Okay, now let us look at the next question. A bullet fired vertically upward from a gun held 2.0 meter above the ground reaches its maximum height in 4 seconds. Calculate its initial velocity. A. 10 meter per second. B. 8 meter per second. C. 40 meter per second. D. 20 meter per second. Take G equals to 10 meter per second squared. Now pay attention. From the question, we are given that the time equals to what? 4 seconds. And because the bullet is fired, the initial velocity is what you are looking for. The final velocity will be 0. The velocity that the bullet reaches before coming down, that is the final velocity. And the velocity at that point is what? It's 0. Are you getting? That is why we have final velocity at 0. Okay? We are given that G equals to 10 meter per second squared. Okay, based on the information that we are given, which of the equation of motion are we going to use? We are going to make use of V equals to U plus A or GT, sorry, U plus GT. Now, because the bullet is moving against gravity, the value of G will be negative. Are you getting it? We're going to have negative here. It is moving upward. Gravity is a force that makes an object to come down. Are you getting it? So it is moving against gravity. So therefore, the value of G will be negative. Now, from the question, you will notice that we are given height. Height is what? The height of the gun above the ground level is 2.0, right? Now, pay attention. Ignore that height. Are you getting it? Just make use of the formula to get your answer. V is 0, so I'm going to have 0 equals to U. U is unknown. That is our parameters that we are looking for. Negative 10 multiplied by 4. So, 0 equals to U minus 40. What will be the value of U? U will be equals to 40 meter per second. Okay? So, the answer to that question is option C. Option C is correct. Okay. Let us proceed to the next question. A stone and a feather are dropped from the same height above the Earth's surface. Ignoring air resistance, which of the following is correct? The stone and feather will both reach the ground level at the same time. B. The stone will reach the ground first. C. The feather will reach the ground first. D. The feather will be blown away by the wind, while stone will drop steadily. Now listen, you know the question says we should ignore the air resistance. Are you getting it? That means mass is inconsequential. We are not going to take into consideration the masses. Of course, you know that the weight of the stone, the mass of the stone is higher than the mass of the feather. Are you getting it? And based on that, if you want to consider the masses, that means the stone will first get to the ground. But now we are asked to ignore the air resistance. So that means both the stone and the feather will get to the ground at the same time. That is the correct option. Are you getting it? The correct option is option A. The stone and the feather will both reach the ground at the same time. Do you understand? A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? A. 5 meters per second squared. B. 25 meters per second squared. C. 20 meters per second squared. D. 2 meters per second squared. Okay, let's start by writing out the information that we're given in the question. The car moves with an initial velocity. So U equals to 25 meters per second, okay? And it reaches the velocity of 45 meters per second. So the final velocity is 45 meters per second, okay? And the time taken to reach that velocity is what? Is 10 seconds, okay? Now we are asked to calculate the acceleration of the car. Acceleration is equals to change in velocity all over change in time, right? So acceleration is equals to 45 minus 25 all over time taken. That is what? 10 minus 0. Acceleration is equals to 20 all over 10, which is equals to 2 meters per second squared, okay? So that is the solution to that question. The correct option is option D. Option D is correct. Okay, let us proceed to the next question. Two balls X and Y weighing 5 grams and 50 kilograms respectively were thrown up vertically at the same time with a velocity of 100 meters per second. How will their positions be 1 second later? That is, what will be their position 1 second later? The first option here, X will be 500 meters ahead of Y. The second option, option B, X and Y will be 500 meters from the point of throw. C, X and Y will be 500 meters from each other. D, Y will be 500 meters ahead of X. The correct option to that question is option B, X and Y will be 500 meters from the point of throw. It is just like the previous question that we did. Are you getting it? Let us proceed to the next question. If it takes an object 3 seconds to fall freely to the ground from a certain height, what is the distance covered by the object? A, 45 meters, B, 60 meters, C, 90 meters, and D, 30 meters. Okay? It takes an object 3 seconds, so T equals to 3. Okay? It takes an object 3 seconds to fall freely to the ground from certain height. That means the initial velocity of the object is 0 because the object is not moving before the fall. Are you getting it? So U equals to 0 here. T equals to 3 seconds. The acceleration due to gravity is 10. Let me check here. Yes, acceleration due to gravity G equals to 10 meters per second squared. Okay. Now, with respect to this information, how can we calculate the height? Because height is distance. In fact, let me change it to h. We are asked to find the height. Recall the second equation of motion, h equals to ut. Now, because the object is moving towards gravity, so we are going to have 4 plus 1 over 2 gt squared. Are you getting it? So the height equals to, now, initial velocity is 0. So 0 times t is what? 0. That means what I'm going to have is 10 multiplied by 3 squared all over 2. H equals to 10 times 9 all over 2. That is 90 all over 2. So the height is equals to 45 meters. And the correct option to that question is option A, 45 meters. Option A is correct. Okay, let's proceed to the next question. Calculate the total distance covered by a train before coming to rest if its initial speed is 30 meters per second with a constant retardation of 0.1 meter squared. Okay. Here, please pay attention. We are asked to calculate the distance covered by a train. We are looking for S. The distance is S. And the initial speed, the initial velocity is U, which is 30 meters per second, okay? The final velocity V will be equals to 0. Are you getting it? Because at the end, the train stopped moving. Are you getting it? So, and the acceleration, the negative acceleration, which is retardation, is equals to 0.1 meter per second squared. Now, with respect to the parameters that were given in the question, we can make use of this formula to calculate the distance. V squared equals to U squared plus 2AS. Now, because the acceleration here is retardation, that means this sign is going to change to negative. Are you getting it? Because now we have negative acceleration. Hello, retardation is negative acceleration. Do you understand? So substitute the values. 0 equals to U squared, that is what? 30 squared minus 2 multiplied by A. A is 0.1 multiplied by S. I'm going to have negative 30 squared is equals to negative 1 over 5 multiplied by the distance which we are looking for. So divide both by negative 1 over 5. I'm going to have negative 900 times negative 5 all over 1 equals to S. So the distance is equals to 4,500 meters. I hope you understand. Maybe you are wondering why this change to multiplication. You can see that I take the inverse of -1/5. So that's why I have multiplication here. Do you understand? So the correct option to that question is, let me check. That is option B. Option B is correct, okay? So let us proceed to the next question. A car starts from rest and moves with a uniform acceleration of 30 meters per second squared for 20 seconds. Calculate the distance covered at the end of the motion. A, 6 km, B, 12 km, C, 18 km, and D, 24 km. Okay. We are given that the car starts from rest. Hello? A car starts from rest. That means that the initial velocity will be what? 0. Okay? And then it moves with uniform acceleration. A equals to 30 meters per second squared. Are you getting it? And the time is equals to 20 seconds. We are asked to calculate the total distance traveled, S. S is not known. Now, how do you find the value of S here? We recall that S is equals to UT plus 1/2 AT squared, right? So S will be equals to, now, initial velocity is 0. So that means that this will be 0. So I'm going to have A. A is 30 multiplied by T squared, that is 20 squared, all over 2, right? So here I'm going to have S equals to 30 multiplied by 400 all over 2. Are you getting it? So S equals to 12,000 all over 2. S equals to 6,000 meters. Okay, our answer was given in kilometers. So I'm going to have S equals to, you know that 1,000 meters equals to 1 kilometer, right? So that means 6,000 meters will be what? 6 kilometers. And the correct option to that question is option A. Option A is correct. Are you getting it? A train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second squared. The time required to bring the train to a complete halt is A, 5 seconds, B, 10 seconds, C, 20 seconds, D, 40 seconds. Initial velocity was given as 20 meters per second. Okay? Now, the deceleration, which is negative acceleration, is equals to 2 meters per second squared. Also, we are asked to calculate the time. The final velocity will be equals to 0. Are you getting it? So from this, we can make use of V equals to U plus AT. Are you getting it? Because we are given all the parameters, and the parameters that we are looking on the that we are looking for is also part, which is time. So V is 0. I'm going to have 0 equals to U, 20. Now, negative acceleration, I'm going to have minus 2t, right? So negative 20 equals to minus 2t. To get the value of t, divide by minus 2. T equals to 10 seconds. And the correct option to that question is option B. Option B is correct. Okay? Let us proceed to the next question. Which type of motion do the wheels of a moving car undergo? I'm very sure you've seen wheel of a moving car before, okay? A, random and translational motion. B, rotational motion and oscillatory motion. C, translational motion and rotational motion. B, vibratory and translational motion. Option D is disqualified. There is nothing like vibratory, but maybe oscillatory. Now, pay attention. Let's say this is the wheel of a car. Are you getting it? When the car is moving, hello? Let's say the car is moving in this direction. Do you know the wheel covers a linear motion? Are you getting it? Because you are going to discover that the direction will be like this. Are you getting it? So it will cover a linear motion. Translational motion is a form of linear motion. Are you getting it? So that means the wheel covered, number 1, translational motion. The motion of the wheel can be said to be translational. Are you getting it? Now, if you look at the center of the wheel, the motion of the wheel is what? Rotational. Are you getting it? So we can also say that the second motion that the wheels is undergoing is a rotational motion. Rotational motion. So therefore, the correct option to that question is option C. Option C is correct. Translational motion and rotational motion. From the diagram above, the region of zero acceleration is A, Mn, B, Ns, C, Sp, D, Pq. Now listen, zero acceleration simply means the acceleration is not changing. Do you understand? There is no acceleration at all. Now listen, from this point to this point, the body accelerates. Are you getting it? It accelerates. From this point to this point, there is no acceleration. Acceleration is constant. From this point to this point, which is Sp, Mn, the body accelerates. Are you getting it? Because you can see that the velocity changes from 0 to, are you getting it? So from Ns, the velocity does not change at all. So the body did not accelerate. The body does not accelerate, no acceleration. And then from Sp, the body also accelerates. And then what of Pq? Pq is deceleration. Are you getting it? The body decelerates. So the correct option to that question is Ns. The body did not accelerate at Ns. The acceleration is 0. So that is option, option B. Yes, option B is correct. Okay. Which of the velocity time graphs shows uniform acceleration of a body from rest? Okay, now listen. Uniform acceleration of a body from rest. That means the initial velocity of that body must be 0. Are you getting it? Now let's go. Check the first paragraph, the first velocity time graph. You can see that even though the body starts from rest here, you can see the acceleration. Acceleration is not uniform. Are you getting it? So this cannot be the answer. What of this? The body starts from rest, but the acceleration also is not uniform. As you can see, it's bent. What of this? The body starts from rest, and the acceleration is uniform because it is just, are you getting it? So the answer is option C. This is the correct answer. Also, if you check the third option, which is option D, the acceleration is not uniform. Are you getting it? So the correct option is option C. Okay? I hope you've seen why option C is correct. If you check the other line, the line bends, you understand? But this one, the line is diagonally straight. So that is the correct option. Now, let's proceed to the next question. A projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. Okay? Taking g equals to 10 meters per second squared. Now, we are looking for the time taken now. Don't forget, in projectiles, the time taken is t equals to 2u sine theta all over g, right? Yes. Theta has been given as 30 degrees. And u equals to 300 meters per second. Are you getting it? So g has also been given as 10 meters per second squared. So all we have to do now is to substitute. Here I'm going to have t equals to 2 multiplied by 300 meters per second multiplied by sine 30 degree all over 10. Are you getting it? I'm going to have t equals to 2 times 300, that is 600. 600 times sine 30 degree is what? 1 over 2, right? So I'm going to have 1 over 2 all over 10. Are you getting it? T, which is the time taken to reach the maximum height, 300. 300 all over 10. So the time taken is equals to 30 seconds. Okay, this time that you have here is the time it takes the object to go up and come down. That is the time of flight. Are you getting it? Now, but our concern is to calculate the time it takes the object to reach the maximum height. Are you getting it? So to get that time, I'm going to divide this time by 2. Are you getting it? Because the time it takes to go up will be the same time it will take the object to come down. Are you getting it? So that means if the time it takes the body to go up is x, it will also be the same time it will take the body to come down. Are you getting it? The same time will be required for the body to come down. So that means x plus x will be equals to what? 30. The total time taken, the time of flight, will be time it takes the body to go up plus the time it takes the body to come down. Are you getting it? So I'm going to have 2x is equals to 30. To get the value of x, what am I going to do? I'm going to divide 30 by 2. So x equals to 30 all over 2. X is equals to 15 seconds. That is the time it takes to reach the maximum height. And the correct option to that question is option D is correct. Option D is correct. Okay? Do you understand? Now, from the question, we are given that the train has an initial velocity of 20 seconds. So u equals to 20 meter per second. Are you getting it? And the deceleration, which is negative acceleration is 2 meter per second squared. Okay? The time required. Okay, now listen. The velocity, the final velocity will be what? 0. Are you getting it? Now, based on the information that we are given, how can we determine the time? Which equation of motion are we going to use? We call that V equals to U plus AT. Now, because the acceleration that we are talking about now is retardation, so therefore the value of the sign that A is going to take is negative. So substituting these parameters, we can easily get the value of T. So I'm going to have 0 equals to 20 minus 2 multiplied by T. Are you getting it? So negative 20 equals to negative 2T. The variables are by negative 2. T is equals to 10 seconds. So therefore, the value and the time taken to bring the train to complete out is 10 seconds. Okay? Let me look at the correct. The correct option to that question is option C. Option C is correct. Okay? Let's proceed to the next question. A football is hit with a velocity of 6 meters per second at an angle of 30 degrees to the horizontal. The time of flight of the ball is A 0.6 seconds, B 0.4 seconds, C 5 seconds, D 0.3 seconds. Okay, we are given that the velocity which the ball was hit is 6 meters per second and theta is equals to 30 degrees. We are asked to calculate the time of flight. Now, the value of G will be 10 meters per second squared, okay? And from projectiles, time of flight equals to 2u sine theta all over G. Are you getting it? So the time of flight will be equals to 2 times 6 multiplied by sine 30 degrees. This all over 10. So the time of flight will be equals to 2 times 6 is what? Is 12. So I'm going to have 12. Now sine 30 degrees is what? 1 over 2. 12 times 1 over 2. This all over 10. Okay. T will be equals to 6 all over 10. That is 0.6 seconds. So the correct option to that question is option A is correct. Okay. Option A is correct. Now, let us proceed to the next question. A car has an initial velocity of 40 meters per second and retards at 3 meters per second squared. Calculate its velocity after 10 seconds. Okay. From the question, we are given that the car has U as 40 meters per second. Are you getting it? And the retardation, which is negative acceleration, is equals to 3 meters per second squared. Okay. We are asked to calculate the velocity after 10 seconds. T equals to 10 seconds. Now, from this question, from the parameters that we are given, which of the equation of motion are we going to use? That is V equals to U plus AT. Are you getting it? So, but because the acceleration is retardation, are you getting it? And retardation is negative acceleration. retardation is negative acceleration. So therefore, the value of A here will be negative. Are you getting it? The sign will be negative. So I'm going to have V equals to U, which is 40, minus acceleration, which is 3 times time, 10. Okay, the velocity will be equals to 40 minus 30. V is equals to 10 meter per second. Are you getting it? So the correct option to that question is option A. Option A is correct. Okay, let us look at the next question. A body moving at 20 meters per second decelerates uniformly at 5 meters per second squared till its speed becomes 10 meters per second. The distance covered within this period is A 30 meters, B 20 meters, C 50 meters, and D 60 meters. We are told that the initial velocity is 20, so 20 meters per second is U, and the final velocity is equals to 10 meters per second. 10 meters per second. The acceleration, the deceleration is what? Deceleration, which is A, is equals to 5 meters per second squared. Please don't be confused. Deceleration and retardation are the same thing. Are you getting it? And they simply means negative acceleration minus A. It will be minus A. Are you getting it? So please don't get confused. Now, our goal is to find S. We are looking for the value of S. Now, from the equation of motion, which are we going to use? Recall that V squared equals to U squared plus 2AS. Now, because the acceleration that we're talking about in the question is deceleration, the sign here will be what? Negative. The reason why I intentionally wrote positive is because I want you to know the reason why we are going to have negative here. Are you getting it? So please pay attention. V squared, okay, V is 10. I'm going to have 10 squared is equals to U squared, which is 20 squared, minus 2 multiplied by 5, minus 2 times 5 times S, okay? 10 squared is 100. 100 equals to 400 minus 10S, okay? 100 minus 400 equals to negative 10S, okay? Negative 10S. Negative 300 is equals to negative 10S. This over negative 10 and this over negative 10. So the value of the distance that the car will cover is what? Is 30 meters, okay? So the correct option to that question is option A. Option A is correct, okay? So that is the solution to that question. So we've come to the end of today's class. If you have any question, let me know in the comment section, okay? And also, before you go, don't forget to hit the like button, subscribe to the channel, share the videos to your friends, and also if you want to join our free online classes, you can check the comment section, check the first comment, click on the link there to join, okay? See you in the next class.